Hi everyone. This lesson is a review for geometry students. This is a review for chapters 5 through 8, including all of this. So let's get started. We have a lot to do. All right, just more learning targets and what we're going to be covering today. So we're going to start off with reviewing sectors and arc length. So the formula for finding a sector, which is a portion of, it's like a fraction of the area of an actual, of a circle. So that's going to be arc degree over 360. That's my fraction times pi r squared. So it's a fraction of the area. My arc length is going to be arc degree over 360 times 2 pi r. Reason for these to be different, arc length is basically here you are walking along the edge of a circle, a pi, or whatever circular shape that you're on. The area of a sector, or the sector, and this is always dealt with area. Area is basically taking this space in between here. And so it's two-dimensional as opposed to walking around this distance like that. And so one is a fraction of the area, one is a fraction of the circumference. So we know that the radius of this shape right here given is 5. And it says find the area and also the arc length, but I want the blue area is what I want. So basically we would take 360 degrees and subtract 120. And what that's going to do is give us 240 because that's the area, that's my arc degree. That's the fraction of 360 that I'm looking at. So if I want the area of this sector, I'm going to use arc degree, which is 240 over 360 degrees times pi r squared. So zeros are going to cancel. I've got 24 over 96. I'm going to divide by 12. It's going to give me 2 and then 3. So it looks like I'm going to have 5 times 5, which is 25, times 2, which is 50 pi over 3. And this is unit squared because that's going to give me my area. So that's the area of that blue space. Arc length. So to find the arc length, also, I'm going to use the same fraction. So arc length, which is this distance of you here walking along the edge. That's the perimeter right there. So 240 over 360 becomes 2/3. So we have 2/3 pi, and then times 2 pi r. R is 5. And so what I have is 2 times 2, which is 4, 4 times 5, which is 20. So I get 20 pi over 3, and this is units. And that's going to give me my arc length. For this problem here, it's asking me for the area of this triangle. What I know is the formula for that is 1/2 ANS, and that's for any regular polygon. That's the area for, a triangle, square, pentagon, any side, any regular where all sides and all angles are congruent. The apothem is 5. So that apothem is this little line right here. What is the radius? So if this is an equilateral triangle, all the angles are going to be 60 degrees. That being said, my radius is always going to divide my apothem. And what that does is, divide that angle where it's at. And so that gives me a 30, 60, 90 right triangle. Across from 30 is 5. Across from the 60 is going to give me 5√3. And across from the 90 is going to give me 2 times whatever's across from my 30. So that's going to give me 10. So my radius length is 10. The side length then, if my base from here to here is 5√3, I'm going to add another 5√3. So that's going to give me 10√3 for the length of a side. So we have 10√3. Now the perimeter is 3 of those. So 10√3 times 3. So 10√3 times 3 is going to equal 30√3. To find the area then, you have 2 options. Option A is to use 1/2 ANS, which is to find the area of the triangle, equilateral, 1/2 my apothem, times the number of sides, which is 3, times the length of one side, which is 10√3. And so I'm going to divide out the 2 with the 10. That makes 5. 5 times 5 is 25. 25 times 3 is 75. and then root 3. And that's the area of this equilateral triangle. And this is unit squared. Area is always going to be unit squared. Keep in mind, though, for a triangle, you could also find the area of a triangle by doing 1/2 the base times the height. And in this shape, my base, again, is 10 root 3. But my height, be careful, because if my apothem, based on an equilateral triangle, this length right here is 1/3 of this whole length. So that would be 5, 10, 15. So my height is actually 15 units. And so 2 divides into 10, 5 times 15, also 75. And then we have root 3 units squared. So either way that you do that, just remember that you, if you're using the apothem, it's 1/3 of the whole length. So you would just multiply by 3 to get that length. If I know that the radius of my square is 3 root 2, and so a couple of ways to do this. So we've got 3 root 2 here. This being a 45, 45, 90, because it's a square, that means the right angle is here. Here's my apothem that comes up and hits it 1/2. But also, if this was a 90 degrees, this now is a 45, and that's where I get the 45, 45, 90. I do have the option of extending this up because that is a diagonal. And that means that my diagonal would then be 6 root 2. That being the case, 6 root 2. So if I want, and don't forget to find the area, because a lot of times you get a side length and you're like, woohoo, do the happy dance. And then, wait, did you answer the question? If you answered the question says find the area of the square, which is side squared. So the area of this square is going to be 36 and then unit squared. For this problem here, it says the perimeter of a regular hexagon is 24. And if I divide this by 6, I'm going to get 4 for each value, 4 for each. Your job is to find the apothem, perimeter, and the area. So first of all, this length here is 2. If all the way around is 4, 4, 4, 4. Again, this is a hexagon. And so one way to find the angles of a hexagon is to use the formula, which is n minus 2 times 180. N being the number of sides, and then take that answer and then divide by the number of sides. So n being 6 minus 2 is 4. 4 times 180 is 720. So we know that the sum of all the angles inside, if I added them all up, is 720 degrees. But if I divide this by 6, because I have 6 sides, then one angle is then 120 degrees. Now remember what I said about the radius. The radius is going to take that 120 degrees and it's going to cut that in half, leaving that to be a 60-degree angle, therefore making that a 30, 60, 90 special right triangle. Opposite the 30 degrees is 2. Opposite the 60 is going to be 2 root 3. And opposite the 90 is double whatever is across from the 30. So that's 4. And hexagons are kind of cool in that it makes this really cool little equilateral triangle inside that you may or may not have noticed. But to find the area of a regular, again, hexagon, we're going to use our 1/2 A and S formula that gives us the area. So 1/2 my apothem, which is 2 root 3, times the number of sides, which is 6, times the length of one side, which is 4. And this is going to give me the area of my hexagon. 2's are going to cancel. And remember, numbers cancel with numbers. Also multiply with numbers. That root 3, don't touch it. So you've got 6 times 4, which is 24. And then 24 root 3 is the area of this hexagon. I wanted just to, this slide is here because I wanted to show you, just again, if you were standing at one of the corners of the hexagon and you decided to divide this hexagon into, different portions, you could find the area by connecting one vertice with each of the corners, the vertices. And so what that means and what that does for us is this. This would give us 180, 180 degrees, 180 degrees, and 180 degrees. So realistically, 180 degrees times 4 is equal to 720 degrees. And that also would give me the sum of the angles in my hexagon. So just like I said, a heads up, then of course I would divide by 6 to get 120 for the measure of one angle. But this is just another way, and it's pretty much the same formula, right? 180 times the number of sides minus 2. That's where that 4 came from, because I have 6 sides. For this problem here, you are to find the area of the parallelogram that has a base of 12. So here's 12. Also has another base of 6, meaning if I turned it on the side, right, up and down, like if I took this and I kind of tilted it like this, then this would be 6 and these would be 12. Your job is to pick however you want to have it, sideways or not sideways, and know that one of the angles is 60 degrees. So what that means is this looks a little larger, so I'm going to say that's 60 degrees. Also, one thing about parallelograms is opposite angles are congruent. Additionally, something about parallelograms is that because the opposite sides are parallel, both pairs of opposite sides are parallel, that also means that these angles are supplementary. So in case I wanted to use a different angle, I absolutely could do that. The area of a parallelogram, so the area of a parallelogram formula is base times height. But very importantly, the base does need to be perpendicular to the height. So if your base is not perpendicular to the height, then you can't use 12 times 6. I can use 12 as my base, but my height is definitely not 6. My height has to be perpendicular. So that's going to go straight down like this. Notice then that I do have a 60-degree angle, which makes that a 30. So across from the 90 is twice what's across from the 30. So that means across from the 30 would be 3. And then across from the 60 would be 3 root 3. And therefore, that is my height. And so remember, numbers get multiplied with numbers. So I would multiply this 12 times this 3. I'm going to get 36 root 3 units squared. And that's the area of my parallelogram. For this problem here, it says that my trapezoid, which I'm going to draw right here, has an area of 75. So the area of my trapezoid, area of a trapezoid is equal to the height divided by 2 times the sum of the bases. Now, I do know that because of the area is 75, I'm going to put the area right here because those are equal to each other. So I would get 75 is equal to the height times 1/2 the sum of my bases. And the reason why I split that up, okay, base 1 plus base 2, is because they did mention that I do have a height of 5. And so what that would do for me is then move this h and put that in as 5. So what I'm trying to find out is how long the median is. And so the median, if you remember, is this line, horizontal line, that is also parallel to both of my bases, but it also cuts, it meets at the midpoint, and so it splits those lengths in half. And so therefore, that's my median. That's the length I want. And if you remember that the median formula is 1/2 the sum of the bases. It's the average of the bases. And so the unique thing about the area of a trapezoid is that it actually has the formula for the median within it. So it's the median times the height. So if I can just solve for this, I actually will have the length of my median, right? So if I just take 75, and I divide that by 5, right? 1, 2, 15. Therefore, the length of my median is 15 units, and that's it, or centimeters, whatever your unit of measurement is. Find the area of the hexagon that has an apothem of 4. So I'm going to draw in the little apothem straight down. We now know, remember, from the last problem that these values are 120, each of the interior angles, and therefore that inside angle here now is 60. So I know that the apothem is 4. I don't have any other information, but I do know that the area of my hexagon is 1/2 my apothem, which I do know is 4. The number of sides, which is 6, and the length of one side, which is the value that I do need. So I have my apothem, I have the number of sides, I just need the length of one side. So in order to do that, if you recall, across from the 60 degrees is equal to a root 3. So one option is to divide by root 3 and then get that value. Our shortcut is taking that value, divide by 3 and multiply by root 3, which is the same thing as dividing by root 3. So my length of this side right here is 4 over 3 root 3. Now I need to double that because right now all I have is this distance from here to here. So times 2 is going to give me 8. Numerators multiply with numerators. So I have 8 root 3 all over 3. So I'm going to do a little reducing before I multiply everything out. I'm going to divide this 2 into this 8 and get 4. I'm going to divide this 3 into this 6 and get 2. This 3 cannot cancel with that root. Remember that. And so we have the area is equal to 4 times 2, which is 8. 8 times 4, which is 32. Root 3 units squared. That's the area. So the circumference of this circumference equals 2 pi r. And that's what they're asking me to find. I want you to sort of highlight that because we don't have any of the information. We don't have the radius in order to find the circumference. But we do know that the area of a circle, so the area of a circle is, the formula is pi r squared. We do have the value of the area, which is 25 pi. So I'm going to plug that in for my area. So 25 pi is equal to pi r squared. If I divide by pi on both sides, those are going to divide out and become 1. I'm left with r squared equals 25. I'm going to square root both sides, and the square root of 25 is plus or minus 5. But remember, for a circle, if I'm trying to find the length of a radius, I'm not going to have a negative value. So then the minus sign is out. Our radius is 5, so that's our answer for the radius, but that's not the actual answer for the question. The question said, find the circumference. So I'm going to take my radius. Circumference equals 2 times pi times my radius, which is 5. And now I have my circumference, which is 10 pi and then units. Find the area of the region bounded by the 60 degrees. So they were going to say there's a 60 degree sector right there. We have radius 6. I want to find this blue area. So the area of a sector, I'll just do that kind of thing. And then hopefully you'll be able to see that that's what an area of a sector might look like, is equal to arc degree over 360 times pi r squared. So again, it's a fraction of the entire area. This is my entire area. This is the fraction of that area. So arc degree, so I'm talking about 60 degrees out of 360 times pi times r is 6, and 6 times 6 is 6 squared. Okay, zeros are going to cancel. 36, these two 6s are going to cancel with those two because that makes 36, and that makes 1, 1. 6 times pi is 6 pi, and so unit squared, and so that's the area of that blue region. If m is negative 3, 3, so 1, 2, 3, 1, 2, 3. Here's the median is negative 3, 3. It says that P has coordinates of 5, 4. So let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4. So here is P. You're trying to find Q, which I'm guessing is somewhere up here. And P is 5, negative 4. The way you're going to find P is what you're going to have to do is you're going to have to realize what the formula for the median is. The formula to find the median, meaning if you have x, y, is equal to the average of each of the values. So to find x, you would add x plus x1 plus x2 and divide by 2. To find y, the median, I'll use m for median. To find the median, you're going to add y1 plus y2 and then divide that by 2. So if I don't know what the x and y is, I'm just going to call it x, y. I don't know what that is. That's what I'm going to be using to find, what that Q point is. So the median is negative 3. So this is to find xm. This is using this formula right here, which is the median, okay, which is negative 3. I have that value, negative 3. So negative 3 equals the first x, which I don't have. So I'm going to go x1 plus x2, which is 5, divided by 2. So I'm going to cross multiply, get negative 6 equals x1 plus 5. and I'm going to subtract 5, I get x1 is equal to negative 11. So far, I've got this value as negative 11. Now, for the median of the y coordinate, I'm going to use this formula right here. And so I'm going to use y1. So y1, which I actually, do I have the x median? I do have the y median, and that's 3. So I'm going to go 3, this value right here, is equal to y1, which I don't know, plus y2, which is negative 4, all over 2. I'm going to cross multiply again. I get 6 equals y1 plus negative 4. I'm going to add 4 to both sides. I get y1 equals 10, which means that my point of Q is negative 11, 10. For this problem here, I want to prove that it's a rhombus. So in order for you to prove something is something, especially a rhombus, 1, 2, 3, 4, 5, 0. And then we have 8, 5, 6, 7, 8, 1, 2, 3, 4. And then we have 3, 1, 2, 3, 1, 2, 3, 4. So we have some options here. So here's my rhombus. A couple of things about a rhombus that you need to know. Number one, it has 4 congruent sides. So we know that it has 4 congruent sides. So I can prove that it's a rhombus by finding the length of each of the sides. Additionally, I could prove that it's a rhombus by saying that the diagonals bisect each other, and not even saying that they bisect each other, but the diagonals are perpendicular. So for me, if I wanted to prove this was a rhombus in the quickest number of steps, I would prove that this is a rhombus because my diagonals would be perpendicular. And for that to happen, I need the slopes. So where I'm going to do that, I have 0, 0. I've got, this is 5, 0. This is 8, 4. And this is 3, 4. So to find the slope of this, what is this? A, here's B, here's C, and here's D. To find the slope of AC. So that's what I'm looking for. I'm going to subtract my y's. So I'm going to go 4 minus 0 over 8 minus 0, which is 4 over 8, which is 1 over 2. So the slope of AC is equal to 1/2. Now I need to find the slope of BD. So the slope of BD, again, I'm going to take my y's and subtract. So I'm going to go 0 minus 4 over 5 minus 3. And I'm going to get negative 4 over 5 minus 3, which is 2. And that becomes negative 2 over 1. Now, if my two slopes are actually perpendicular, then I can multiply 1/2 times negative 2 over 1, and I'm going to get negative 1, which therefore means that my slopes are perpendicular. So you would say AC, put a little line over that because you're talking about that length, not a measurement, is perpendicular to BD. And if this was a rhombus, then that would happen, and that these would be perpendicular. For these problems here, they're asking you to find various values. For this one here, you could set up a proportion, and you can say 2x plus 1 over 7 is equal to 18 over 6. I would cross multiply. Actually, even before I cross multiplied, I would reduce this right side. And 18 over 6 is actually 3 over 1. And so I'm going to make this 3 over 1. And what that's going to do is just lower the numbers a little bit. Now, 7 times 3 is 21. That equals 1 times 2x plus 1. I get 2x is equal to 20, and so therefore x does equal 10. So for this second problem, we're going to make a proportion. We're going to say 2y is to 5 as 14 is to 6. I'm going to cross multiply, and also just a heads up, you can reduce when you have a fraction, numerator and denominator together. So meaning I could divide by 2 and make this 7 over 3. And then when I cross multiply, I just have smaller numbers. So 2y times 3 is 6y, 5 times 7 is 35. And then when I divide this out, I get y equals 35 over 6. You could, another option, just, to throw this out there, Another option would be to do something like this, where you would write, let's say 14 plus 6 over 6 is equal to 2y plus 5 over 5. And just, just heads up, that's like how they do on the SAT a lot of times, where that's just another way to write the proportion, and you could still cross multiply and solve and you still get the same answer. It's just another way to write it, okay? For this problem here, we know that the whole length is 12, and we know this length from here to here is z. So therefore, this length from here to here would be 12 minus z. So when I set up this proportion, I'm going to go left side is to left side. So I'm going to go 10 is to z as 8 is to 12 minus z. I'm going to cross multiply. I get 10 times 12 minus z is equal to 8z. I either can divide by 10 or distribute. So that's just, like completely an option. I'm going to distribute. I get 120 minus 10z is equal to 8z. I'm going to get my z's together. So that's 18z is equal to 120. And if I divided that out, what is that? 120 divided by 18 equals z. If I divided by 6, I'd get z equals 20 over 3. And then there's your answer. For these problems here, more similarity problems, we know that AB is 12. We know BD is 3. AC is 10. CE is y. BC is x. And DE is 8. To find y, I would go 10 is to y. Left side is to left side, as 12 is to 3. So I could do that. Cross multiply. Actually, again, look here. 12 over 3 is just 4 over 1. So when I cross multiply, I get 4y is equal to 10 times 1. Y is equal to 10 over 4, which is, if I divide by 2, I get 5 over 2, 5 halves, and which is, so y is equal to 2.5 or 5 halves. In order to find x, I have to do something a little different. And you have the option of splitting up your triangles, large to small. And if this is x, and I'm trying to find x, and I know this is 8, of course, my first proportion ratio is going to be x is to 8. So as I set up my proportion from that first ratio, I went small is to large. So then I would go small being this is 12, large being this is 12 plus 3, which is 15. So I'd go 12 is to 15. And again, I can cancel these out. 12 over 15, I could divide by 3 and 3, so that's 4/5. So when I cross multiply, I get 5x equals 32. So x equals 32 divided by 5. And then that's my answer. For these two problems, I am trying to figure out, A, if they're similar. I want to write a similarity statement, and then I want to say why they're similar, if they are. And the ways that you would say two triangles are similar would be either angle-angle similarity, side angle side, side side, or angle side angle. Oh, any of those would work. These are all our similarity postulates. For this triangle, it is a little bit tricky, for sure. I love this because, I mean, just giving A a value, you know that if I split these two triangles up, see this triangle right here, if I took this out, that triangle, and then I have the larger triangle, right? The larger, whatever that looks like. And then these two angles, A is going to be the same. So regardless if I gave it a degree, 50, 30, whatever you want to give it, the smaller triangle has another angle of 85. The larger triangle has another angle of 85. It doesn't matter what the values are. It just, what matters is that these have to be congruent. And so therefore, this is just angle-angle similarity. So these are similar by angle-angle similarity. My similarity statement would be that triangle CAD is similar to EAB. Okay, and you just write it like that. For these two triangles here, to try to figure out if these two triangles are not congruent, but similar, the only option for this, since I don't have any angles other than the vertical angle in the middle, if these two triangles are similar, if they are, they would be similar by side angle side similarity. Okay? That being said, they would only be similar if the sides are proportional. Okay? Because you can have two angles and no sides, and the two triangles are similar, no matter what, every time. But if I don't have any sides, then I would have to prove that the sides are proportional. So you would go 12:9, largest to small, as large 10 is to small, 7.5. And if you cross multiply and you go 9 times 10, does that equal 7.5 times 12? And they do. They're both equal to 90. Therefore, if the sides are proportional, then the triangles are similar. So we know that because this is 90 equals 90, therefore my sides are proportional, check. And if my sides are proportional, my triangles are similar. Okay. For this one, the angles are congruent, meaning like these are corresponding angles. These are angles congruent. The two triangles are similar. Because the two triangles are similar, I can set up a proportion, and that's what you're looking at. So we know that CE is 9. We know that BC, this whole length here, is 36, which would make this 27. We know that AB is 48, so this whole length is 48, and we're trying to find X. So again, with this problem, you can just say side is to side, but you cannot say 48 is to X. Don't do that. You would need to say this side is 48 minus X, because the whole length is 48 minus this little part, which is X. So that side is 48 minus X. So you're going to set up your proportion like this, and you're going to say 48 minus X is to X. So you're going this side is to this side, as this side is to this side. So as 27 is to 9. And then just once again, anytime that you can cancel something out, just try to make life a little easier for you. 9 divides into 27 3 times. This is 3 over 1. So when I cross multiply, I get 3 times X, which is 3X, is equal to 1 times 48 minus X, and that's that. Add X to both sides, I get 4X equals 48 divided by 4. X is equal to 12. Be careful what they're asking you, because I got X is equal to 12. But if I had been asked what like the length of BD was, I would have to say 48 minus 12, right? But they didn't ask me this length. They actually asked me what the length of AD was, and AD is my X value, so therefore that's 12. To do the second part over here, I have to erase this. And so to do this second part, I'm going to put new values in. And I maybe use a different color if I can. And so AD is 4, so there's 4. DB is 6, DE is 8, and I want to find AC. So this is similar to the problem that we did previous on a different page. And I went, the 8 is to X, so 8 is to X. So I went the small triangle is to the large base, so the 8 is to X, as, and then I would say 6 is to the large length, which is 10. And I would cross multiply, of course, but again, cancel if you can. If that makes you comfortable, if you feel comfortable canceling, divide by 2, you get 3 over 5, and it's just a smaller number. So you have 8 over X equals 3 over 5. You just have a smaller number to multiply, and I don't know, maybe that's easier. 3X equals 40, and then divide by 3, you get 40 over 3. So this is asking you to solve these without using the Pythagorean theorem. What that means is they want you to use the shortcut. Now, of course, there's multiple ways to do this, okay? Hands down. There's, you can use Pythagorean theorem. Even though they say that, I mean, they're not, it doesn't really matter how you get to the answer that makes most sense to you. I could say x squared plus x squared is equal to 24 squared. Definitely can do this, equals to 24 squared. divide by 2, take the square root of both sides. I'm going to end up getting x equals 12 root 2. Another option is to actually use not Pythagorean theorem, but like trig. To use trig, put yourself at an angle, and this is my adjacent side. I could do cosine of 45 degrees is equal to the adjacent side over the hypotenuse, which is 24. And when I cross multiply, I actually get 16.97. So x is about 16.97. What that means is if in my answer column or my multiple choice section, I have exact values like this, all I would need to do was to go 12 times root 2 on my calculator that I'm allowed to use. And I'm going to get about 16.97 and check that's my answer. Okay. But what they actually really want you to do is to use the shortcut. Okay. X root 2. So if I had set 24 equal to x root 2, I could divide by root 2 on both sides. That's what they want you to do. The rule is basically divide by 2, multiply by root 2. And that's with 45, 45, 90s. So basically I'd take the 24 divided by 2. I get 12 root 2. And that's the length of one side. Doing it this without the shortcut, just this way, you still are dividing by root 2. But and these cancel and you get x by itself. But you have to deal with the root on the denominator. And that means that I can't leave that root down there. So I would multiply by root 2. Because root 2 times root 2 is just 2. So what this ends up being is 24 root 2 on the top, this times this, over 2, which is, do you see this? You guys, this is the shortcut right here. That's where that's from. All right. And so then you would go 24 divided by 2 is 12, and that'd be 12 root 2. Same concept. They want you to work backwards. Yes, I can use trig because I have the angles. I could definitely use trigonometry. But what they want you to do is to be able to work backwards. So I'm going to start off putting this 5 here. If I know 5 is across from my 30 degrees, so normally this is how it would work. Across from the 30 is your A value. Across from the 90 is your 2A value. And across from the 60 is your A root 3 value. So if across from the 30 is 5, then across from the 90 is 2 times 5, which is 10. And then across from the 60 would be 5 root 3. If I were to move that 5 and put it, let's say, over here and work backwards, across from the 90 is equal to 2 times what's opposite the 30. So what's opposite the 30 would be half of 5. So either 5 halves or 2.5. So then across from the 60 would be 2.5, or you could say 5 halves root 3. All right. So then what if, though, that this was all changed because across from the 60 is 5. The shortcut is what they want you to use without using Pythagorean theorem. By the way, you don't have two sides to use Pythagorean theorem, so that's like out anyways. But across from the 60, is equal to A root 3. So similarly, in the last problem that we did, where you divided by 2 and multiplied by root 3, the shortcut is to divide by 3 and multiply by root 3. In which case, I would take my 5 and divide by 3 and multiply by root 3, and that is my answer. I'm done. For this problem here, your job is to find the angle, the value of angle. I'm going to call it just theta. You can call it x, you can call it theta, call it whatever makes you happy. It's just the angle. And what you need to use is your sine, cosine, and tangent. So put yourself at the angle, okay? Remember your Sohcahtoa, Sohcahtoa. And what this means is, it's a mnemonic, by the way. That means sine of an angle. Angle is always opposite the word. Sine of an angle is equal to the opposite side over the hypotenuse. Cosine of an angle is equal to the adjacent side over the hypotenuse. And tangent of an angle is equal to the opposite side over the adjacent side. So depending on where you're at is going to depend on, of course, what you're going to use, either sine, cosine, or tangent. What you do need to remember is, and what most people get confused is which side is my adjacent side. Now, my adjacent side is the one I can reach out and touch. It's like my arm is reaching out next to it and I can touch it. So if I was reaching out my arm here, this right here would be the side that I could touch. We call that the adjacent side. This side, which is opposite the right angle, even though I can reach out and touch that side, it's the hypotenuse because it's opposite the right angle, which means that the 5 is my opposite side. So I have the opposite side, okay? I have the opposite side and I have the hypotenuse, and I'm trying to find theta, my angle. So what uses the opposite side and the hypotenuse is sine. So I'm going to say sine of the angle, I am trying to find that angle. Sine of the angle is equal to the opposite side over the hypotenuse, which is 7.8. Now, I do want to solve for theta. Theta needs to be by itself. In order to get theta by itself, or the angle by itself, this sine, I am going to move to the other side of the equation. The act of moving that to the other side of the equation, it is an inverse, but we actually call it arc sine. We have a name for it. It's called arc sine. So when you move sine over to the other side, it becomes arc sine, and then you have 5 divided by 7.8, okay? And so theta is equal to arc sine of 5 over 7.8. And so you need to use your calculator to solve that. Now, one way to do that, let me see where my calculator is. Let's see, where is it? There it is. Okay, so in using this calculator, see if I can make it so that you can see it also. Shrink it down here. Okay, so I think you can see it right here. I want to use arc sine of 5 divided by 7.8. So that means when I use my calculator, let me clear this out. I'm going to go, and by the way, you need to make sure that you're in degrees. See the degrees up here? Make sure you're in degrees. So we're going to go second sine, that's arc sine, and I forgot what it was, 5 divided by 7.8. So we're going to go 5 divided by, type in 7.8, close your parentheses, and hit enter. And that's about 39.8, so about 40 degrees. All right. So again, remember, you have to hit the second button. If you're trying to find an angle, that's when you're going to use arc sine, arc cosine, or arc tangent. All right. Okay. So what did we get? 40 degrees. So it's about 40 degrees. So theta is about 40 degrees. And so that would be this angle down here. Remember that both this angle and this angle here add up to be 90. So this would be about 50 degrees if I wanted that value as well. Solving the proportions for each diagram. So for this problem, this set of problem here, this is just saying, hey, how would I do this? The formula is just side is to side. So you're going to go B is to G is equal to A is to N. Okay. And of course, there's other ways to do that. I could have said A is to B as N is to G, or you could flip these. There's lots of ways to do that. I just like left is to left. It's just whatever you remember. For this one also, so I'm going to go 9 is to 10 minus x as 6 is to x. Of course, I could have gone 9 is to 6 as 10 minus x equals to x. And you can set up these proportions when these sides are equal, when that makes it a proportional triangle. 9x is equal to 6 times 10 minus x. So 9x is equal to 60 minus 6x. I'm going to add 6x. I get 15x equals 60. So then x equals 4. For this problem here also, I would go 15 over 10 is equal to y over 14. I would simplify this left side and divide by 5. Dividing these by 5, that gives me 3 halves. And so when I cross multiply, I get 42. 3 times 14 equals 2y. Whoops. So y is equal to, I'm going to divide both sides by 2, and I get y is equal to 21. For this problem, you do need to know how to use Pythagorean Theorem. In order to find this extra side, the missing side, which is a leg, you've got leg squared plus leg squared is equal to my hypotenuse squared. So I have x squared plus quantity, 2 root 5, quantity squared, is equal to 6 squared. Excuse me. I'm so sorry. That was awful. Okay. Anyway, so we have x squared plus 2 root 5 times 2 root 5 is equal to 36. Alrighty. I don't think I've ever done that before on camera. Anyway, okay, so we have x squared plus. Numbers get multiplied with numbers. So this 2 cancels or multiplies with this 2, all right? So you've got 2 times 2, which is 4. And then root 5 times root 5 is 5. So 4 times 5 is 20. So equals 36. So if I subtract 20 from both sides, I get x squared is equal to 16, which means x equals 4. Okay. For this problem here, this is very similar to that other problem where we have x root 2. So again, we know that this is a 45, 45, 90 because two sides are congruent. And if my sides are congruent, then my angles are congruent, which makes it a 45, 45, 90. So 12 divided by 2 multiplied by root 2, I get 6 root 2. And again, there are multiple ways to do this. This is just one way of doing this. Though for this one down here, this is one of the geometric mean problems where you have basis to height as height is to base. Okay, so you're going to go 7 is to x as x is to 2. Cross multiply, so x squared equals 14, so x equals the square root of 14. Now, this is definitely not the only way to do this. But one way to do this, we know that x is the square root of 14. Just leave it like that because now I have to use the Pythagorean theorem to find z. So I'm going to go the square root of 14 quantity squared plus 2 squared equals z squared. So 14 plus 4, which is 18, is equal to z squared. And when I square root both sides, I get the square root of 9 times the square root of 2 is equal to z. And that makes z equal to 3 root 2. So there's 3 root 2. And lastly, to find y, I would go 7 squared plus the square root of 14 quantity squared is equal to y squared, y being my hypotenuse. So we go 49 plus 14, which is 63. So 63 is equal to y squared. And then square root both sides, y equals the square root of 9 times the square root of 7, which is 3 root 7. So 3 root 7. For this one, we're going to use Sohcahtoa, our sine, cosine, and tangent. So we've got Sohcahtoa. And so put yourself at an angle. I'm going to put myself at this angle, and I know this is 11 degrees because 79 plus 11 is 90. And so I'm trying to find this opposite side. So I'm going to use tangent. So I'm going to go tangent of the angle is equal to the opposite side over the adjacent side. Now remember, not a degree. Remember that the adjacent side is the side you can reach out and touch. The other side is the side that's the hypotenuse, but actually we're not even looking for the hypotenuse yet. Cross multiply, x equals 18 times tangent of 11. So we go x equals, and I would just use my calculator. I have that here. 18 times tangent of 11. There it is. So tangent of 11. So I'm going to go tangent of 11. I'm going to get that number. And then I'm going to multiply by 18 times 18. And I get about 3.5. Remember, though, that you're not using arctangent because you're not trying to find an angle. You only use arctangent when you're finding an angle. That's it. So about 3.5 is where we're at, okay? So right now, we know that x is about 3.5. So 3.5. So I'm going to lose this place here, and I'm going to make this 3.5. So now I have to find this length here. Now you have options, of course. You can use Pythagorean Theorem, 3.5 quantity squared plus 18 squared equals the hypotenuse squared. I could use that, or I can also use sine, which would be sine of 11 degrees is equal to the opposite side over the hypotenuse, or I could use cosine. of an angle, which is 11 degrees, is equal to cosine adjacent side over the hypotenuse. So I'm just going to use that. I'm going to cross multiply. I get a times cosine of 11 equals 18. And so a is equal to 18 divided by parentheses cosine of 11 degrees. Make sure that you use parentheses, because if not, your calculator is not going to like that. 18 divided by cosine 11. So let's do that. 18, so 1/8 divided by cosine, use parentheses. Cosine, what did I say, 11? Close the parentheses. I'm in degrees, enter. So that's like 18.3. So this value here is about 18.3. Now, just to confirm, right, 18.3, remember the smallest side is opposite the smallest angle. So my smallest angle is 11, and this is definitely my smallest side. And my largest side is opposite my largest angle, which is apropos for what we have here. Because remember, even though 79 degrees is not, it's close to 90, but not quite, your angle, your side is going to be closer than the other one. So here we go. The diagonals of a rhombus are 6 and 12. So if I wanted to find the area, heads up, area for a rhombus is just 1/2 diagonal 1 times diagonal 2. I would go 1/2 of 6 times 12, but they're not asking me that. They're not asking me what the area is. They're asking me what the perimeter is, and so therefore not the area. So remember to read the question. Diagonals of a rhombus are 6 and 12, which would make this 3 and 3. It would make this 6 and 6, and it would make this a right angle in there because my diagonals not only are they bisect each other, right? So they cut that in half. I need to find, in order to find the perimeter, I need this length. In order to find that length, this isn't a special right triangle, so therefore it's just a right triangle. I'm going to use Pythagorean Theorem. 3 squared plus 6 squared equals that side squared. So I have 9 plus 36, which is 45, is equal to x squared. So I'm going to square root both sides, and when I do that, I get x equals, the square root of 45 is breaking that down to the square root of 9 times the square root of 5, which is 3 root 5. So if one of my sides is 3 root 5, option A is to just count 3 root 5 plus 3 root 5 plus 3 root 5 plus 3 root 5. So what is that? 4, 3 root 5. So that's going to be 12. 3, 6, 9, 12 root 5. And this is units because it's perimeter. Or I could have just taken 3 root 5 and multiplying it by 4 sides. And remember, numbers get multiplied by numbers. So that would have been 12 root 5. Again, same thing. The grade of Pacheco Pass is 6%, which means that's 6 over 100. That's your rise over your run, okay? This is a right angle. Altitudes are always right angles. They want to know the angle of elevation. So again, they want theta. I don't have the hypotenuse. I'm not looking for the hypotenuse. I'm not going to use sine, and I'm not going to use cosine. I have to use tangent because tangent's the only one that does not use the hypotenuse. So we would say tangent of the angle is equal to the opposite side over the adjacent that you can reach out and touch. I'm going to get tangent on the other side so I can solve for theta. Move tangent to the other side. When you do that, it becomes arctangent. So now I have arctangent of 6 over 100. And I'm going to use my calculator and maybe. So I'm going to use my calculator, and so I'm going to go, let's see, I have 2 calculators now. Let's see, I want to use arctangent of 6 over 100. So because I'm looking for an angle, I have to go second tangent so I can get that blue part up on top. So 6 divided by 100, and you don't have to reduce that. It's not going to make any difference at all. It's about 3.4 degrees. So that makes theta, my degree, theta equals about 3.4 degrees, okay? Standing 30 feet away from the Titan gym, here that is, here, Here's my right angle. I'm 30 feet away. You measure an angle of elevation, is that angle going up. 38 is right here. Your eyes are 5 feet above, so that's 5 feet from the ground. How tall is the gym? Well, the gym is that tall, so it's going to be 5 plus whatever x is. So let's find x, okay? Let's find x, and then we'll add it to 5. Don't forget to add it to 5, though. And so what we're going to do is we're going to put ourselves here, okay? And that makes opposite and adjacent. So that's tangent again. So we're going to use tangent of 38 is equal to x over 30. I'm going to cross multiply. X equals 30 times tangent of 38. And so x equals 30 times tangent of 38. So tangent, let's see, tangent of 38 is equal to, and I have to multiply it by 30. So multiply that value, so times. So you just go times and it picks up that answer. Times 30, and I get about 23.4. Don't forget, you still have to add 5 because of the height. So we're at 28.4. So x, or the height, so x was 23.4, but then we took that 23.4 and added the height and got 28.4 is the height of the Titan gym. For this problem here, we're trying to find the scale factor, ratio of perimeters, etc. What you know is that if you can separate your two triangles, or these aren't triangles, these are rectangles. If you separate those, you've got 30 here and 40, and you've got 45 here. And in order to find the scale factor, I have to compare two corresponding sides. And I don't have that. So therefore, I can't compare 30 to this side because I don't have that. I can't compare this side to 45 because I don't have that. I don't have this side. So I also can't compare 40 to x because I don't have x. So what we have to do first is set up a proportion because they're telling us that they're similar. So therefore, because they're similar, we can create a proportion for the sides. So we're going to go 30 is to, well, I don't know. What do we want? We definitely want to do this. And we want to go 30 is to 40. I'm going to do that. 30 is to 4. Well, actually, we can't do that, can we? Because they're not, we don't have the sides. We don't have enough sides. So in order to find the ratio of perimeters, I have to compare the sides. But I know this side, this is 30. And so we can go 30 is to 45. Oh, silly. As 40 is to x. So before I do this and before I cross multiply, I really want to reduce this. And so reduce 30 and 45, I'm going to divide by 5. And I'm going to get 6. Ooh, I should have thought of a bigger number. I don't know, like 15. So 15 is going to give me 2 and 3. And so that's 15 times 2 is 30, and 15 times 3 is 45, so that works. So we're going to get 2x is equal to 3 times 40, and so x is equal to 3 times 20, which is 60. So we found x. But in retrospect, actually, 40 is to 60 is one of my options. 4 is to 6, which is 2 is to 3. But I just completely overlooked that. These are the same size. And 45 also 45 here. So 30 is to 45. Also, my scale factor is 2 to 3. Anyway, once you have your scale factor, then what you need to do is find the ratio of perimeters, which you can actually add up all the perimeters, compare the perimeters. But realistically, the ratio of perimeters is the same as my scale factor. So if my scale factor is 2 to 3, then my ratio of perimeters also 2 to 3. And the only other thing is my ratio of areas, which is a little different. My ratio of perimeters is 2 to 3, so my ratio of areas is going to be 2 to 3 quantity squared, which will be 4 over 9. And so that would be, that's my ratio of areas. as opposed to the ratio of scale factor is here. My ratio of perimeter is here. This makes my ratio of areas, okay? Find the scale factor, ratio of perimeters, ratio of areas. Also, same thing. 4:5 is my scale factor. So that's my scale factor. It means that my ratio of perimeters, also 4/5. My ratio of areas is going to be 4/5 quantity squared, which is 16/25. Done. But they said prove it. So prove it. If I wanted to prove it, scale factor, that's just comparing your ratio of radii. Check, we did that. But the ratio of perimeter is 2 pi r for a circle. So 2 times pi times 4 over 2 times pi over 5. So 2's are going to cancel, pi's are going to cancel. I'm left with 4/5. That's my ratio of areas, my ratio of perimeters, which in a circle is my circumference. Then my ratio of areas is pi r squared, 4 times 4, over pi, 5 times 5. Pi's are going to cancel. I get 16/25, proved, okay? Last group of problems. You do need to be able to multiply. So 4 times x plus 7 is equal to 3 times 2x minus 5. 4x plus 28 equals 6x minus 15. Subtract your x's, you get 2x. Add 15 to 28, and I get 43. Is that right? 5, 2, 3, 4. And divide by 2, I get 43/2. Leave it. Cross multiply, x squared, x times x is x squared, equals this quantity, which is x minus 2 times x plus 5. Now for this, though, I do have to FOIL. And then I get x squared plus 5 minus 2, which is plus 3x. And then negative 2 times 5, which is negative 10. My x's are going to cancel. My x squareds are going to cancel. I get 0 equals 3x minus 10. I'm going to move the 10 to the other side. I get 10 equals 3x, and so x equals 10/3. And lastly, in order to find the geometric mean, which is what we did on this other problem where you've got this, where you had the right triangle like this is what it's asking. 5 here, unknown, 8. This is your geometric mean. So you're going to go 5 is to x as x is to 8. You're going to cross multiply, x squared equals 40. Square root both sides, and when you do that, you get x equals the square root of 4 times the square root of 10, which is 2√10. And so that's your geometric mean. Check. That's it. That's all I have for you, you guys. Good luck. Study for your midterm. Work ahead and complete worksheet number 5 because it is rather long. Wishing you the best, and I'll see you on midterm day. Good luck. Oh, thanks for watching.